This is section 5.5. It's on side, 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 and side, angle, side shortcuts. When you see these three letters, you read it as side, side, side. It's natural to say SSS. It's natural to want to say S, but you need to say side, side, side. Likewise, this is side, angle, side. Don't say SAS. Don't say SAS. It's side, angle, side. These are shortcuts for showing that triangles are congruent. So postulate 5.1 is your side, side, side postulate. It's our first shortcut for showing that triangles are congruent. Last section, we learned to have two congruent triangles, you need 6 pairs of congruent parts. Well, this side, side, side postulate says you don't need 6 pairs. You only need 3. And the 3 pairs that you need are just the pairs of sides. That's why there's 3 S's. So each S stands for a pair of congruent sides. So as long as you have 3 pairs of congruent sides, these two triangles must be exactly the same size and shape. So we're going to use that shortcut a lot. Here's some examples. Are these triangles congruent? If so, write a congruent statement and the reason they are congruent. I see a pair of congruent sides. I see a second pair of congruent sides. And I see a third pair of congruent sides. If you can count 3 pairs of congruent sides, then your triangles are congruent. So are the triangles congruent? Yes. If so, write a congruent statement and the reason that they're congruent. Well, I'm going to name this triangle any way I want. L, N, M. It's congruent to this triangle. S, Q, R. It's important to line up the corresponding parts. For example, L is in between a side with 1 mark and 3 marks. So is S. N is in between sides with 2 marks and 3 marks. So is Q. That's how I knew what went with what. They're congruent by side, side, side. Three pairs of congruent sides. What about these triangles? There's 2 triangles here. There's a yellow one and a green one. I see a pair of congruent sides, and I see a second pair of congruent sides. I do not see a third pair. But if you look closer, this is segment YW, and it's on both triangles. So regardless of how long it is, wouldn't it be the same length as itself? That's the reflexive property. We're going to use that reflexive property a lot. The reflexive property tells you that if you have a shared part, then it's congruent to itself. So now we have 3 pairs of congruent sides. So are these triangles congruent? Yes. Let's write a congruent statement. We'll call this triangle ZYW. It's going to be congruent to the green triangle. Just watch your order. Notice how Z is in between 1 mark and 2 marks. So is X. Y on the yellow triangle is in between 2 marks and 3 marks. So is W. W on the yellow triangle is in between 1 mark and 3 marks. I know it's weird that W goes with Y and Y goes with W, but that's the way it is because this triangle, it's reflected and turned into that position. And that happens sometimes.